Today we're going to use SprutCAM to create the toolpaths to cut the sonar mount for the TeachSTEM Now BasicBot. We've already imported our IGES file and we've set the orientation of the X, Y, and Z axes the way that we want them. This time we're going to take special care to make this an easy project for students to create a post file. And we're going to use some fairly simple operations which may not necessarily be the most efficient, but because this is a small part, it's going to be worth doing so that all students will be successful at creating their first CAM profile. The operations we're going to be using are the roughing waterline, the finishing waterline, we'll use flatland finishing, and then finally we're going to cut a couple of pockets. So we'll start by creating our roughing waterline operation. And once we create it, we can see that if we hit run, SprutCAM will find a rough way around the part. However, we can tell just by looking at it that this is not going to be as detailed as we want it to be. And that's simply because this end mill is a little bit big for the job. So the first thing we'll do is go into parameters and adjust the size of the end mill to something a little bit more realistic. And we'll go down and we're going to use a 1/4 inch 2-flute end mill, making sure that the numbers match as we select it. We'll hit run again and run a simulation just to double check. We can see the tool comes down, and it takes a little bit of extra time to make these cuts, but it does rough out the part pretty well. We're going to go ahead and stop that for now. We'll come back to it later. One thing that we want to do for the purposes of safe and accurate machining is we're going to want to leave a little bit of material down on the bottom here. That's one technique that we use in class. Sometimes we'll use tabs as well, but right now we're going to go ahead and set the parameters to leave us a little bit of material on the bottom. So we go to parameters, and we like to have a Z retract height of about 1/2 inch just for safety. We'll leave our top level at 0. Now the depth of the part is about 0.32 inches, and we're going to leave a couple hundredths extra, so we're going to have it cut to 0.31 or 0.30 rather. We can adjust these other parameters as well depending on the material we're using and the tools. This part will be cut out of plastic most likely, or you can use aluminum and then powder coat it, but plastic is the best material because it is non-conductive, and because this is an open PCB based product, the sonar sensor that we're using, it's best to make sure that there's no way that you can have any short circuits, so we cut this out of plastic. Let's go ahead and run the model again and simulate. Reset. And it will leave, if you look at the toolpath, it will leave a little bit of material on the bottom. Let's go to our next operation, which is going to be a finishing waterline. And you can see, by the way, that students did not have to actually select any edges, any faces, or any other parts, which makes it super easy for them to get started in CNC this way. So our finishing waterline, simply select, create, and let SprutCAM do the rest. We want to make sure that we select the right tool again, and 1/2 inch is too big. Let's go ahead and make a smaller choice. We use our 1/4 inch 2-flute. See how that works. Hit run. That doesn't look right. We'll double check that real quickly. We did not hit the select button. There we go. You can see the end mill is a little bit more acceptable now. Hit run, simulate. And away it goes. If we look at this, we can see that a fair bit of material is being left that's not cut out. That's unacceptable, so we're going to have to drop down to a smaller end mill. Let's see what we can do. Our next choice for end mill in our tool list is going to be an 1/8 inch. It should do the job just fine. Make sure the tools match in number. Hit select, say OK. Quite a bit smaller, hit run. And that's going to be just fine. You can see by the tool path that get some nice cuts. One parameter that we need to adjust just to make sure that we don't cut too deep is the same one we did before. Let's make sure our bottom level is set to 0.30. We're not going to need to make 12 cuts. This is plastic. Even though it's a small end mill, we can probably do this in 3 or 4 cuts. We'll hit run. Let's do our next operation, the flatland finishing. Select flatland finishing, create. Let's check our tool. We'll use our 1/8 inch again. It's a fairly detailed bit of machining here. Check our parameters. Make that 0.5 again. And we want to make sure we don't cut below 0.3. Let's see how it looks. You can see we're going to be making a lot of passes here, but it's going to end up with a nicely finished part. Again, notice that students have not had to select anything on the part itself, which makes it really easy for them to make things work. Finally, we're going to go ahead and cut out the eye holes, if you will, for the sonar sensor. And in order to do that, we're going to do a new operation of pocketing. Pocketing is found under roughing. And this time we will be selecting the edges of the holes. Do that edge. Make sure that we're on Job Assignment tab, and we'll hit Add Pocket, and we'll do the same thing here, and Add Pocket. Now we can see, just a quick observation, that this pocket is far too tall and far too deep, so we'll be making some adjustments. We'll double click and let's check our tool out first. We can use a 1/4 inch end mill on this. And retract height, we'll have it 0.5, the usual. This time we'll leave our top level at 0.15. and we want to make sure that we go all the way through the part. So we're going to go ahead and set our bottom level at 0.33. And we can see here there's a little bit of time wasting because the tool height is a little bit higher than where the actual cut's going to begin, but that's fine for now. Students can make adjustments as they see fit. That's the beauty of the simulation model. Once the toolpath is generated, we can simulate it, and we can watch the tool do its job. Once the complete toolpath has been generated, we take a look at it, make sure everything makes sense. Nothing's going to interfere with anything else, and all of the operations have green checks on them. You'll notice on the flatline finishing operation that there actually is an error message, and students should investigate something like this to make sure that there's not going to be a problem when actually machining the part on the CNC. The way to do that is take a look at by going to simulation, click on the operation that seems to be the problem, and you can actually dive into the exact spot where the problem is. If you look here, you can see that SprutCAM is having a slight issue with the height of the tool versus the height of the step here and the part. In actual fact, that happens on all of these steps. This is where the sonar will be mounted onto physically, and it's not a problem in reality, so we're just going to go ahead and ignore that particular item. And once we run the complete simulation, we'll see that everything checks out just fine. So that concludes the SprutCAM tutorial for the Teach STEM Now Basic Bot with the brand new sonar sensor. Hope you enjoyed it, and stay tuned for more.